So let's start getting into it. If you guys want to, you should probably follow along for this workshop. So make sure you have Inventor installed and hopefully open on a screen. You can even put me on your phone or something if that works out for you. By the way, there's a handout PDF version of the workshop we're doing today that I put in the workshop main chat, so you can go see that in there. And if you get lost at all, you can either rewind the YouTube stream or you can go check out that handout in there. And at the end, you're just going to save your part as an STL, and we'll provide a Google Drive link where you can just fill it like a short survey and upload your STL, and that'll get you your bonus marks. So I'm going to go ahead and start. The part we're going to be making today, not this whole thing, I showed this at the start of the last workshop. So this is the entire assembly we're going to be making over the course of our entire workshop series. So, as you can see, we have just a pretty simplistic style drone here, right? With 4 arms, 4 blades. Someone is not muted. I'm going to mute them. There we go. So we have it's a pretty simplistic drone here with 4 arms. It's pretty nice looking. Leo made this, by the way, so if anyone has any design questions about the drone, you can ask Leo. Sort of put you on blast, Leo. But yeah, here it is. So last time we made these lovely support legs down here, which were a pretty nice way to start off the series. There might have been some more difficult aspects of it last time, but this time we're going to stray away from the sweeps and such, and it's going to be more focused around sketching and extruding. Hopefully you guys maybe have a version of these parts sitting around, because next workshop, the one after this, we're going to be assembling everything and putting all these parts together. But for this workshop, we're going to be making another one of these parts, and that is this top sort of lid part you see here. So if I hide everything else, turn the visibility off, this is what we're going to be making today. So just kind of giving it a quick glance, you can see it's not too complicated looking, right? And if you really know your stuff, you should be able to whip it up in about maybe 10 or 15 minutes. We're going to be making this over a course of maybe about 45 minutes today. And then at the end, I might go over some last little bit of principles about how you might assemble this together onto your main drone part. So I'm actually going to go ahead and get started here. We're going to be recreating this. So I am going to go File, New up at the top. So if you guys have your Inventor open, just go File and New, and it should open this dialog box here, this file browser. And if you don't see any of these items here on the right side, just make sure you might just have like English US selected. Just go ahead and expand all these folders until you see one that's called metric. And click on the metric one, and then you can go ahead and click standard millimeter.ipt. And that should open up a new part area. So this is kind of our new part design screen, basically, right? So we don't actually have anything in here yet, so you can see it's completely empty at the moment. So if I go back to my my part, you can see you can sort of see the general shape of it, right? You might get some ideas of where we want to start here. So one part you could sort of choose to start with is maybe this sort of block, this sort of L block rectangular shape down in the bottom. But for this workshop, we're going to be starting somewhere else. We're going to be starting with this sort of top portion here. So hopefully you guys all have at least opened Inventor before and made something in it. So I'm going to run on those assumptions. But again, if you have any questions at all, my tech team is fully available for you in the help rooms, or you can just message me. So I'm going to go ahead and start a new 2D sketch. So just click this button here in the top left, and that should show these 3 design planes for you. So we have the XZ plane, XY plane, and YZ plane. And I believe we're going to be starting on the XZ plane today. So assuming you just still have the Start 2D Sketch button clicked, just go ahead and click the XZ plane. That is the one that's sort of lying flat, almost horizontally. And then it should open up your sketching screen, which basically turns your 3D view into a 2D view. So you can see we have one axis going down vertically and one axis going across horizontally. So everything you do in CAD, you almost always start with a 2D shape, and you stretch that and deform it in order to make 3D geometry. So that's what we're going to be doing today. We're going to be starting with one of the most basic things you can do in Inventor, if not the most basic, and that's going to be making just a simple rectangle centered around the sort of middle of our screen. So the handout says you can use a 2-point rectangle, which you definitely can. I'm going to be using a 2-point center rectangle just as a matter of personal preference. So go ahead and select one of those two tools. Maybe best if you just follow along with me. Go ahead and select 2-point center. And now we're going to be making a rectangle that's 100 millimeters tall, like vertically, and 90 millimeters wide horizontally. And to start that off, since I've selected the 2-point center rectangle tool, basically what that one does is you select where the center is going to be first, and then it automatically morphs the rectangle out both sideways and vertically. So I'm going to go ahead and use this tool, and I'm going to center it on my origin. So everything you do in a sketch needs to be constrained about a certain point, and the point where to start constraining is always the origin. So if you can start a shape by connecting it to the origin, then your shape is always going to be like fully constrained as long as all the other parts are properly defined. So to know if something is being constrained to the origin properly, you will see this green dot appear underneath your cursor. So as long as I'm hovering over there correctly, I just go ahead and click when I see the green dot, and then I can slowly kind of morph out my shape here. Now I said the dimensions we wanted were 100 tall by 90 wide. So you can see a sort of like a blue highlighted box as you're going out. Before you even click anything, you can actually just type on your keyboard what the dimension is. So the blue highlighted box is my vertical dimension there, and I want that one to be 100 millimeters, so I'm going to type in 100 there. And now to do the same thing for the horizontal box, I can just click Tab on my keyboard. So again, just to reiterate, to change the horizontal dimension here before we even click anything, I can hit Tab, and then it'll change my dimensioning box to the 78.89 millimeters up there on the horizontal, and I'm going to type 90 millimeters on my keyboard. So 90. You don't even need to type millimeters. You can, but since we made our part in the millimeter environment, we don't actually need to type millimeters. We can just type 90, and it should make it just like that. And ta-da, that's all we're doing for this sketch. See, as easy as it gets, as easy as it gets. So just to go back and just to reiterate that again, once you're done this, you just click Finish Sketch here up at the top, and it should return you to your sort of 3D modeling environment. You can see up here 3D model. That's how you know you're not in a sketch or anything. You're in your 3D modeling environment. So now that we've made our sketch, you can sort of see what I've done here. What I've done is basically I've made the rectangle that defines the overall dimensions looking from the top, save for this little back piece here, this little block on the end. So it's everything over from that. So I'm going to go ahead and click Extrude here up at the top just to make my simple rectangular prism shape. And I'm going to extrude that by 10 millimeters. It should be the default, unless you were working on something earlier in Inventor and you used a different value. Then you might have whatever value you used in there. Sometimes it saved it, but by default it should be 10. So as long as your distance here is 10 in the box, you should be good. If it's not, just go ahead and highlight it and click 10. You don't need to change any of these other things. I mean, as long as your preview looks similar to mine. And then you just go ahead and click OK. Now we're going to be starting another sketch, and if you look at the handout, it says to make a sketch on one of the 100 millimeter faces. So just looking at it visually right now, it looks like these ones are these ones here going vertically on my screen right now. These are our 100 millimeter lines. Just gonna check my Discord, make sure everything is all right, real quick. Yep, no issues so far. Sounds good. Also, if you guys have any other issues, you're welcome to use the chat in YouTube as well. And I'm gonna make another poll that you guys can use. Oh, I have to end the previous one first. Hold on. And yeah, it didn't work. All right, I feel like a boomer using this YouTube Live. Okay. Sorry, I'll try. Oh, okay. Yeah, it ended the poll. I'm just gonna make another poll for you guys to use in the YouTube, and that's just gonna ask like if there's anything wrong with the pace, if you think it's too fast, if you think it's too slow, or if you think it's just right. You can just vote on there in the YouTube live chat, so that way you can tell me to speed up if I'm going too slow. So that'll just take me a couple seconds here. Just right. Okay. So there should be a new poll popping up soon. I just submitted it, so it should show up soon. But just use that, and I'll try and check it in the next like 5 minutes or so. So to continue on, to get to the chase, I'm going to start a new sketch on this face here. So that's one of our 100 millimeter sides. And to get going, I'm going to be starting. I have this sketch going, and I'm going to make a shape here with the line tool. So if you go up at the top left, next to your Start 2D Sketch button, you should have a line tool available here, like line, circle, arc, rectangle. So we're going to be using just a simple line tool here. And now I want to make a shape that looks similar to this profile we see here. So this profile that comes down and out like this, we're going to be making a shape similar to that. So with my line tool, I'm just going to go ahead and start with that first line going down vertically. So we can use the same principles we did before. See how we have that highlighted blue box there. I'm going to go ahead and type 5 on my keyboard. That is going to be the distance we're using vertically here, 5 millimeters. 5 millimeters down from our bottom edge. And if I tab over, I'm just going to make this one 90, just to be sure. 90 degrees, so it's at a right angle from the bottom line of our part. And there we go. Now, if you've been taught a bit about Inventor before, you'll probably know that green lines are typically bad. Green lines means it's not fully constrained in that you can move it about your part. So if I click Escape here, just to exit my line tool real quick, and I try to click and drag this, you can see I can click and drag it around. That's because it's not constrained. The only constraints I have on it right now are this end of it is connected to this line, and I know that's 5 millimeters long and it's going vertically, but I can move it in this direction. So if I wanted to define the distance, say between this edge and this edge, to do that, I just use the dimension tool here up at the top. So click dimension. And now we click the line we just made. That's that green one that's going down vertically. So we click that. And then we click our leftmost edge of our part here that we've made, our 3D part. And now you can see it tells you the distance here, the 13.566 millimeters. So if we click that down on our screen, we can actually change that distance. So if I click it down up here, it opens up this dialog box for me. And you can see it's highlighted in here. You can actually type in here. So if I remove all of that. Now the distance I want to make it between these two lines is 15 millimeters. So I'm going to go ahead and click 15. So if you guys are finding anything wrong with the pace, hopefully everyone can see the poll in the YouTube. So I'm going to go ahead and exit out of my dimension tool by clicking the escape button on my keyboard. Now that's a really important thing about Inventor. If you ever find yourself stuck in a tool, like for some reason all you can do is like make a million rectangles and you can't actually click anything without making a rectangle like this, just click escape is the safest bet. If your cursor, when you're clicking down, is doing something absurd or something really just destroying your entire part, just click escape. And then whatever happens, you can just Control Z on your keyboard to remove whatever you made. So that is the escape tool. The escape button is your friend, probably your biggest friend in Inventor, in my opinion, besides your mouse, obviously. Definitely recommend using a mouse for any type of CAD. Now, the next portion we're going to be making is just the horizontal section that comes out a little bit more. So to do that, you just go ahead and go back to your line tool. And you want to start your line at the end of the last line we just made. So I'm going to go ahead and hover over. I'm just going to do that again, just to show it again. I'm just going to go ahead and hover over the end of my line. And as long as you see that green dot, that means it's fully constrained to that line that we've already made. So I'm going to go ahead and click that. And now this next line we're going to be making is 7.5 millimeters long, just horizontally. So as long as it looks like that, it should be good. Now I'm going to be speeding up this next portion just a little bit. We're going to make another line going down. As long as you still have your line tool, you should be good to go. It's going to be going down vertically by 5 millimeters. And then you can make another one going all the way to the center of the part. So just make sure it's at a 90 degrees from the last line you just made. And actually, something that happens that you might notice is if you hover over right around the center of the part, as long as it's horizontal, if you hover right over the center, you can see a sort of dotted vertical line there, and that means it's automatically adding a constraint there. So it's if I click that down, it's actually fully constrained. I can't actually move that around. Oh wait, yes I can, because I guess not. So there's actually a few ways. Basically, what I wanted to do right now is I want to make the end of our line vertically consistent with the center of this line here. And there's a couple ways we can do that. Just knowing the geometry, I could just say I could just make this line 42.5 because I know that this entire portion is 100 millimeters long. And I know we're out by 7.5 here. So 7.5 on this side, 7.5 on that side. You know, you can do the math. Another thing you could do is you could use the dimension tool, click on the end of that line, and then click on the center of this line, and then drag it out down like this. And that'll, since I already have a dimension there, that'll tell me, no, you can't do that. Another thing I could do, well, it's not so. Another thing I could do is just make a vertical constraint here up at the top. Basically what that does is it makes any point vertically aligned with another point. So if I just do that, you can see it pops up just like that. So you can use any of those techniques. If you missed one, you can just replay if you want. Otherwise, just ask questions in the Discord. The last thing we're going to be doing is making another line that connects those two pieces just like this. Easy peasy. And now what I'm going to be doing is I'm going to be mirroring this sketch around the center of our part here. And I'll show you probably the most efficient way to do that. So this last line we just made, you can actually, we're going to be using this not for geometry purposes. We're going to be using it as a reference to mirror our sketch. So I'm going to right click that after I have it selected, and I make it a construction line. If you right click it and then hit construction here, it turns into a construction line. And what a construction line is basically when you're making extrusions and everything, it won't, the 3D modeling environment won't recognize construction lines as geometry. And so if you have, like, for example, if you have a rectangle made entirely out of construction lines, you won't be able to extrude it, right? So what you can use construction lines for is you can use them for references for using different tools in Inventor. So in this case, I'm going to be using the mirror tool. So ensuring you're still in your sketching environment, just go up here to the mirror tool in the pattern section, click mirror, and now it'll open up this dialog box here. So there's a button that says select. So as long as you have this button here, the select one, selected, just go ahead and click all your lines. As soon as you have all your lines clicked, all 4 of these ones, make sure they're blue, click on the mirror line button. And then once you have this mirror line button selected, you can select your construction line, and that should be selected. You won't get a preview for it just yet, but if you've done it properly, you can click apply and then done. And you can see it's actually made a mirrored image of my sketch. Now, you're probably wondering like, oh, well, you could have just gone over and just done the same thing on the other side manually. Yeah, you could have, definitely. The reason mirrors are a good practice is because if you want to go back and change your part later, when you're actually designing things, it's an iterative process, right? So if you want to go back and change it later, it's really easy to change both sides. It saves yourself a ton of time. So instead of changing, say if I wanted to change this length to 5 instead of 7.5, I wouldn't have to change it twice. I just have to change it once. So if it's shortened on this side, and it automatically shortened on this side as well. So that's the power of mirrors. I'm just going to go ahead and Control Z that. But this is exactly what we need for our sketch. So I'm going to go ahead and click Finish Sketch. So I do realize I'm taking a little long with some of this stuff. So I'm probably going to try and speed it up a little bit here. Does anyone have any questions so far at all? Just anything in general? I'll be able to hear you in Discord if there's any problems. If not, then I will keep on going. Cool. So the next part we're going to be doing here is just extruding this new shape we made out. So as long as you click the extrude button up here at the top, it'll probably automatically select the sketch you made. If it doesn't, you can just go ahead and actually click on the sketch you made. If you really can't get it to extrude out any geometry, that means there's likely an issue with your sketch. If so, just go ahead and type something in one of the help rooms, and someone will come along and try and help you fix your sketch. Cool. So I want to actually extrude it out this way, so it's underneath the rest of our part. And in order to change directions, there's a really easy button here that just says direction underneath behavior. Your dialog box might look a little bit different depending on what version of Inventor you have. But if yours looks like mine, you can just click the flipped direction and it'll automatically change the direction there of your extrusion. So we're actually going to change the distance of that extrusion, and we're going to extrude it out 80 millimeters, just like this. And there we go. If your part looks sort of similar to mine here, you're doing well so far. And I'm going to keep on going. So actually, yeah, I'm gonna finish like the next feature, and then we'll take a quick break just if people need to, use the washroom or anything like that, or have any questions. So the next part we're doing here is another super simple part. We're just going to be making another extrusion here on the end. If you look on the part I have, you can sort of see our part is starting to look a little bit like it, right? Hi, did someone have a question? No? Okay, no, sorry, I just heard something over the Discord. Never mind. I'm gonna mute that person. I can't hear. Right. Okay, so the next part here, I'm just gonna go ahead and make this another rectangular block, essentially, that goes underneath here. So to do that, I'm just gonna go ahead and make a new sketch on this face here. And I'm gonna make a rectangular sketch that just goes around the entire sort of outer dimensions of this part. So I'm gonna make a rectangle, a 2-point rectangle, and I'm gonna start it going from, let's say, the origin corner I have here, or just the corner of your part. As long as you see that green dot underneath your cursor, you should be good to go. Now we're just gonna extrude that out. Sorry, not extrude it. We're just gonna sketch that out. 2-point center, 2-point rectangle. It should be 100 wide by 20 tall, so 100 by 20, and that should follow the outer dimensions of our part. That's all you need to do for this sketch. You can just go ahead and click Finish Sketch there, and then you can click the Extrude tool, and mine's automatically extruding in the right direction. I'm just going to extrude that out again by another 10 millimeters. And so this should be pretty simple stuff so far. All we've done is extrusions. But you can sort of start to see the shape of our part take form here. But now we've got the more basic overall dimensions down. Now we're going to be doing a little bit of, we're playing with some planes and some more sketches as well to get the last of these few features down. So we're going to be doing this node here up at the top. We're going to be doing these counterbored holes, this entire fillet going around the whole thing, as well as this little feature down here on the bottom. That's all we have left to go. So I'm just going to take like maybe a 30-second break. If anyone has any questions at all, you can throw them in the YouTube chat if you want. You can throw them in the Discord chat. I don't see anything in the YouTube chat so far, so no worries there. But I'll just take another 30 seconds. Now, I'll go back to my part here. And the next little bit we're going to be doing is we're just going to be adding those sort of rounded edges, the rounded parts of this top edge here. So you don't have to do these now. Usually I leave these till the end, but we'll try and be consistent with the handout. It doesn't really present any issues, so it should be fine. So this part is super easy, and it'll make you feel super cool. If you've used Inventor, you've probably used fillets before, but I'm just going to reiterate again. So a fillet is basically just rounding off any edge. So it's easier if I show you than just tell you. So if I just click an edge here, you can see it rounds it off. And this is really important in mechanical engineering, especially, or if you're just making parts out of metal, because there's lots of safety standards in place saying that you should never have sharp edges on a part that you're manufacturing. If not, you can get like sued if someone from assembly, rips their entire hand open. When I was on co-op, we actually had a big issue with sharp edges where the person who was going around and removing all the sharp edges actually cut open their work glove, like sliced it open right down the middle, probably missed their skin by like a millimeter or something. That's how sharp the part was. It just cut open their glove entirely, just like that. And the ironic part was this is the person who was supposed to be removing the sharp edges from the part. So yeah, you can see this kind of a bit of a weird area there. What we ended up having to do as a fix was a lot of these pieces of metal were machined through CNC. So you program a machine and it automatically makes the part for you. So what we had to do is we had to add the fillet requirement, this rounding off the edges part, into the actual machining process instead of the manual part clearing process, essentially. Just to get back to the workshop here, I'm going to be applying a 10 millimeter fillet to my top 4 edges of my part here. So if you click on all 4 of these edges and you ensure your dialog box here has 10 millimeters in the box. If it looks a little different, you might have to just click wherever it says 10 millimeters. Just double click it and it should let you type in there. And you just ensure all these sides here are selected just like that. And boom, you click OK, and all of a sudden your part just looks so much nicer, It just looks a lot more professional. It's like fillets, put that shit on everything. So like at the end, you could just if you want, when you're done designing a part, you just fillet all your edges and it makes it look super cool. But to get back to the matter at hand, we're going to be starting another sketch. Because the next part we're going to be making, if I go back to my sample here, is we're going to be making this little tab here down at the sort of around the middle on the bottom of our top shape. So to do that, we're going to be making a sketch. I can rotate my part. If you want, you guys can use your view cube here up at the top. You can click on some of the edges to change your view. or you can left click it and just drag it around just like that. Or if you want to be the most efficient, you can use Shift middle mouse button. If you hold Shift and hold your middle mouse button, you can actually rotate your part around. You can actually change that in the settings if you want to just be your middle mouse button, which I've done here as well. But that saves you a ton of time, and it gives you much more precise movement of your model as well, instead of just like your default 45-degree angles from the view cube. All right, so I'm going to be starting a new sketch here on the bottom of our part. And so when you do so, your part should look something like this. Now I'm going to be making a rectangular shape, sort of right around the middle section of where the bottom profile meets the top profile here. So what I'm going to be doing here is I'm going to be making a rectangle that's 4 by 4. So, and when you're making it, ensure you're selecting along the line for your first corner. So this pre-existing line that we have here from our 3D geometry, ensure you select that, and then this corner should be attached basically to this profile that we've already made. Now I'm going to make it a 4 by 4 rectangle, just like that. Now if I click Escape on my rectangle tool, you can see I can still move this around. So in order to constrain that into place, let's see here, can I, I'm just looking for a way I can actually just constrain it right down the middle here. Let's see, if I make this 40, if I make, okay. So basically we just want this to be centered around here. Since I don't have anything I can click on in our sketch currently, technically I could like enable one of these planes and use it as a reference. But I'm not gonna do that. I'm just gonna do a little math here. I know that this entire piece was 85, was it 85 wide? Yeah, so I'm going to be doing, what is it, 40.5? See if that looks good. Yeah, so just make one of the edges 40.5 away from one of these edges. That's probably the simplest way you can pull it off here. And now for the next part, since our shape is like a little, basically it's like a box and then a circle here. Just for the next part, you can make a circle, just a center point circle, center it on the middle part of your top horizontal line of your sketch here. So when you see the green dot over the middle part of that line, just go ahead and click it, start making your shape, and this circle is going to be 5 millimeters in diameter. And that's actually all we have to do for this sketch. So I'm going to go ahead and click Finish Sketch, and as long as you have something that looks like this, you're on the right track. And I'm going to be doing an extrusion here. And if it only extrudes one piece of your part just like this, don't worry about it, because you can actually click the remaining closed shapes of your sketch just like that. And it should make this nice little, almost looks like a keyhole shape here. So if only one part of your profile is selected, just make sure you click in the other ones as well. And we're going to be extruding this out by 2 millimeters. So there we go. As long as you have 2 typed in there, just go ahead and click OK. So cool. We've only got a couple things left we have to do. If I go back here, all I have to do now is make these counterbored holes here around the corners and this top tab portion. So I'm just going to go ahead and just get it done. I'm going to go ahead and click Start 2D Sketch. Probably going to rotate that around just so that we're looking at it from this side. So If you've been following along pretty much exactly with me so far, the view cube should look like this, sort of top spilled upside down. Now to make the counterbored holes, all we actually have to do on this sketch is make a couple points. So you go up here. We actually have a point as part of our sketching toolbox here up at the top. So we've got lines, circles, arcs, rectangles. We also have points, which is just like, it has no width, it has nothing, it's just like a point in space, right? So I'm going to place down a couple points here. I'm going to place them kind of arbitrarily around. It might be extremely hard to see because the color it automatically gets is green, like a really light green, and it's so hard to see on this part. So sorry if you can't see that. I'll try and select them here so that you can. If you just place them down kind of arbitrarily wherever in space, we're actually going to be applying dimensions to these so that it's not so random. Now, if I try to dimension this, I can actually dimension it. So if you just click the dimension tool, I'll just go say that again. If you click the dimension tool up at the top, and then you click on one of your points, as long as you can find them, you can actually define the distances between this point and these lines here. So I'm actually going to make this point 5 millimeters away from this line that we already have on the top of our box, just like this. And I could make another dimension. Basically, I want to align this point just like that, vertically, just like that. There's 3 ways you can do it. I was about to say 2, but I just saw the 3rd way right there. So if you click Escape on your keyboard so you don't have any tools selected, and you just click and hold, click and drag your point around until it shows up with this dotted line along the vertical line there, it automatically, well, does it automatically apply the constraint? I don't know, but it puts it on the right point in space. So that's one way you could do it, but you can see it's still green when I do that, so it's not technically constrained. One way you could do it, you could use a vertical constraint, just like this, and then you could select this line. But it's not letting us use this line as a reference because it's not projected. So if I project it just like that, it'll probably let me do it now. And no, it still won't. Okay, that's fine. The last way we can do it is just using the dimension tool, clicking on the point, clicking on this line, and then just saying 0, just like that. And if you can see, it almost looks like the point disappears because it's sort of underneath these dimensions, but trust me, it's there. And then we can just do the same thing on the other side. Do 5 and 0. Oops, not 10. And there we go, just like that. So we have our points. So basically, what we're going to be doing is we're going to be using these points to make holes with the hole tool. Now, the handout will mention you can use extrudes for this as well. So if you want, you can do that. But this is the way I'm going to be doing it for the workshop because I find the hole tool is an extremely powerful tool to use. And it'll probably be really helpful for you guys in future projects. So I'm going to go back to my part and I'm going to click Finish Sketch with our just 2 points placed down, or two points defined at a place in space. So we have our points there and there. And now we're going to go up at the top. As long as you click Finish Sketch, you should be back in the 3D Model tab here. Now we're going to go to the Hole tool in the Modify section. Now, in the Hole tool, you can see when it opens up, it gives you kind of a lot of different options here. So there's a simple hole that you can make, which is just a simple clearance straight hole going down, just like that, done. Or you can make, well, a clearance hole, which is the similar thing, just with standard sizes, essentially. You can make tapped holes, so if you want some threads in there to put a screw in it, you can make a tapped hole. Or you can make a taper tapped hole, which is similar, just the top neck of it tapered. In this case, let's just make a simple hole. So let's keep it simple. And in the seat part, we're going to make it a counterbore. Now, a counterbore is essentially like, you've probably seen these screws before, like those socket head cap screws. that have like a head on them. So if you don't want your screw to be sticking out from the top of your part, you want to counterboard it so it's like sitting underneath the sort of top face of your part, right? So it's nice and clean looking. So in this case, we're going to be making a counterboard, and you can actually change. And this, as long as you're using a simple hole tool, you can actually manually change the dimensions of it in here. So my main, actually I'll do it with the counterboard diameter first. The counterboard diameter is going to be 7. So that counterboard diameter is referring to that part, which is essentially housing the head of your screw. And the main diameter here, you can sort of change it by just clicking on these numbers in this diagram. And the main hole diameter is going to be 5 millimeters. So now we have our proper diameters and everything. And all it has to do in this case is go all the way through our part. So as long as it's looking like it's going all the way through, we should be good. If you're not sure, you can just click through all. That's one way of doing it. Or you can click 2 for termination. So when you click 2 as a termination, it's basically saying you go to this point, and you can select another point on your part for it to go to. That's like the ending point. So if the distance between like this top face here and this bottom face is 10 millimeters, then it'll be the same as applying a distance of drilling 10 millimeters. So I'm going to just do that. I'm going to use 2, and I click on the bottom face here, and then click OK. Now we should have some holes selected here. However, it looks like my counterbores are too shallow, so I'm going to be changing the depth of this counterbore downwards 4 millimeters. So as long as you change this dimension here to 4, you should be good. Do they go all the way through? Yes, they do. So that is how you make the counterboard holes. And if you ever have to go back and change a feature, for example, if we wanted to go back and change that hole we just made like I did there, you go here onto the left menu into your model tree, and you just select that feature. You can right click and go edit feature, or you can just double click it, and it should open up the interface, the same interface from when you originally made it. And you just click OK. Now we're getting towards the end of this part. I should post the the submission location now. Sorry, I got a little carried away here. Just looking for it. Cool. All right. So if you guys have already gone ahead and done everything, I'm going to post the submission location. So if you guys have already gone ahead and made your part, or whatever, if you're somehow done, you can go ahead and click the link I just sent in the announcements in the Discord. And in there, it's going to take you to a link. Here, I'll just show you, actually. So if you're already done, it'll take you to this link. You type in your first name, your last name, what faculty you're most likely engineering, yada, 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 just some quick questions. You can even type like NA to these if they don't apply to you. So you most likely want to fill it yes to that part there. And then some feedback for the workshop, obviously. So if this YouTube Live thing you find isn't really working for you, let us know, for sure. Like, we're definitely open for feedback. We want you guys to have the best experience possible. That is why we do this. So your feedback is very important to us, as every telemarketer says. And then to actually get the bonus marks, just upload a copy of your STL file here, and then you can click submit. And I'll show you how to make an STL file in a few minutes, just after we're done the next part. I can go over it super quickly now. In case you're super desperate to get going, you can go save as, save copy as, and then save as type, and you go STL files here. And then you just name your name or your McMaster email or something like that, and then you can upload that in the form. I'm going to go ahead and finish off making this part though. So we've done everything in this part except for making this top thing. this top antenna holder is actually what it is. So if I reveal everything else in this drone again, you can see this actually is holding this antenna in place. So that's the reason. If you want to see kind of the reason for all these parts that we've been designing, you can see it on my screen here. I'm not going to provide the drone file to you guys yet. That'll come later, next workshop. But you can sort of see a similar profile that this lid goes on top of, right? So you can see the profile fits into here just like a slot, almost like a slotted box, right? And we have these screws that we just made, and you can see the head on the screws that I was just referring to with the counterboards. So that's kind of to give you guys perspective of how we've been designing this. I'm going to go ahead and get to the chase. I'm going to start making the rest of this part. And to make the tab here up at the top, we're going to have to make an offset plane, because we're going to be sketching on it just like this. Making the profile just like yada yada yada, circle there, another lines there, that kind of thing. But we don't have a sketch to really put it on just yet. So what I have to do here is I have to make an offset plane that we can start a sketch on. So I'm going to go up here into the plane tool up at the top, go offset from plane, and I'm going to click this edge, sort of like the outer part of our L shape, the bottom part of our L shape, that flat face. And I'm going to click it, and I'm going to bring it out this way by minus 12.5. I just so happened to get it there first try just by clicking and dragging it. But if you can't click and drag it as precisely, just go ahead and type it right in the dialog box there. And once you do that, you can select it. You can actually make it bigger too by just kind of clicking on the corners and clicking and dragging it around. Just like this. Yeah, the planes don't really stay in place all that well, but it doesn't really matter because it's just a plane. When we sketch on it, it's just going to disappear anyways. So I'm going to start a new 2D sketch on this plane. Comme ça. So now we're going to make our sketch here. To start off, let's make a line starting from the top edge, going vertically by about 3 millimeters. Oops, that was not right. Let's try that again. Top edge, and I don't trust it right now, so I'm just gonna go ahead and place it down arbitrarily and then make my dimension. So 3 millimeters, just like that. And now I'm going to set a distance of that because I can still move it horizontally like this. So I'm going to make another dimension. I'm going to say it's a dimension between the line itself and then this line down here, the sort of edge of the strip profile that we have. And once I've selected that, I can just place down my dimension, type in 20 millimeters here. 20. And there we go. We've made our first line of this sketch. And now I'm going to do, let's see here. Okay. Now I'm going to make a circle right from the tip of the line that we just made. So make another center point circle, just like this. And I'm going to make it 4 millimeters in diameter. Just like that. And once you've made it, you can click escape on your keyboard, just like I just did. And now we have the circle. But we still need a profile connecting it to the rest of our shape. So we're just going to make some straight lines traveling tangentially down from the circle down to our part. So go to your line tool. It'll probably automatically find the quadrants of your circle here. If you just hover over it, you can sort of see the dotted line there. So you can try and get it automatically. And if you see, it's hard for me to point out on the screen right now, but right where I just clicked on, that sort of cross-section between my new line I'm currently making and the circle, you can see a little symbol there that's like a straight line and a circle. That means it's automatically applying a tangential constraint to this line. So we won't actually have to add that tangential constraint to it. We're going to make it 3 millimeters down. Same thing on the other side, just like that. If you have any troubles with that, you can add some dimensions to it, ensure that it's 3 millimeters, just like this, or you can use a tangential constraint as well. As long as your line is vertical and connected to this bottom portion here, you can just click on your line, click on the circle, and it should make it. And it should connect your pieces. Since I've already have tangential constraints on mine, it shows up as just like error because you can't make two of the same constraint, obviously. All right, now we've made our profile. I'm going to click Finish Sketch. I'm going to extrude that out. Make sure you select all your profiles. I'm going to make 3 millimeters wide, just like this. And yeah, that's it for that extrusion there. And we're just going to add another little cutout to it because if you looked back on the if you look back on our drone here, there actually needs to be a spot for the antenna to sit inside, right? This is actually installed inside this piece. So I'm actually just going to go ahead and make that little cutout. And you guys can you could even figure that out on your own for sure. I'm positive, but I'm just going to show it real quick. Just make a sketch on this face. You just make a circle going out like this. Make it 3 millimeters in diameter. And then once it's placed on here, you can see it's just kind of arbitrarily placed right now. I'm going to make a concentric constraint. Now, concentric constraint just basically matches up the radius of one shape to another one. So if you look at this image here, the circle is offset from the arc. Their centers aren't at the same point. But what this tool does is it connects the centers. So I'm going to use this constraint tool. I'm going to click on my circle, and I'm going to click on the profile I've just made, and it will match up the centers just like that. And if you have more complex curved geometry, and you don't necessarily know all the math behind it, this tool is extremely good for just lining up the centers of arcs and circles. So now that we've done that, I think that's all I need to do, and then I can just extrude it out. And that should be, no, not quite. It looks like there's a little bit more. But I'm just gonna make like a through all sort of cut out of this, just like this. So I just want this extrusion to cut away all the material from my newest circle, right? So the antenna is actually going to sit in this cutout piece. And to do that, you don't even need to, you could define a distance of like 100 millimeters if you wanted, it doesn't matter. Or you could use through all, which is just infinitely long. It cuts away everything in its path. So that's what I'm going to do. Hit OK. And one last little piece, actually. We just need to add the backing onto this because you can see here that there's a little bit of it jutting out. There actually is a different way of doing it. You could make separate extrusions for your connection profile and your original circle profile, and because they were actually separate shapes in the original sketch. But for now, we're just going to make a new sketch right on top of here. We're going to make another circle right in the middle of them. This one is also going to be, I think it was 4. Yep. Just make it concentric like we did before. Bing, bang, boom. Finish the sketch. Extrude it out. You can do like 1 maybe. 1 or 0.5. I think 1 is probably pretty safe. And hell, if we wanted to even make this like look a little neater, we could even add tiny little fillets on here. Like, I don't know, like a 0.5 maybe. So, you know, something like that makes it look a little fancier, you know. But yeah, that is pretty much our entire part. We can actually right click this plane and deselect the visibility on it. But yeah, this is pretty much the whole thing. If you guys have any trouble at all making this part, just let us know. we're going to stick around a little bit after the workshop. The last thing I'm going to go over is just saving STL files. So one last time, to submit your part to the forum that I showed you here, that I've also posted, just go ahead and go File, and click the arrow next to Save As, and then click Save Copy As, just there, and save it wherever you want, wherever you're comfortable saving it. If you have like a CAD folder, put it there, and then in this drop down, you just select STL files, just like that, and then you just give it a name. I'll just call it Drone Housing Lid, just like that, and then you can save it, and done. And then you can just upload that file in the forum, and you will get your bonus. Promise you. I'm probably going to take like a 2-minute break, and I'll just, like, the workshop is done, so if you guys are comfortable leaving, you can leave now. I'll probably go back on the Discord call now with my audio, and just turn off my stream audio, but I'll keep my screen sharing, even though there's a little bit of a delay. So if there's anything anyone wants to see in CAD, just let me know in the Discord. Yeah, and I'll be sure to show it to you, or someone else from MDL will be happy to show it to you as well. So if you're having trouble with assemblies or anything like that, let us know. Or if you don't know how to use an emboss or a rib or a loft or a sweep or anything like that, let us know. We'll show you how to use it, because there's actually a lot of really interesting tools in here. But for now, thank you so much for coming to the workshop. I'll say this is like the official like credits section, and then I'll just do the post credits later. But thanks so much for coming to the workshop. Hopefully you guys learned a thing or two. If you didn't, next week we'll be speeding things up a little bit. We're going to be doing a lot of stuff in assembly, so putting all these parts together. You can see in my overall drone assembly here, there's a lot of stuff. So it's really important to learn how to put all these pieces together, and hopefully you guys will enjoy it and really get something out of it. Hopefully this workshop was at least really good at reinforcing your current knowledge as well. But yeah, thanks for coming. I'm just going to take maybe a 1-minute break, and if anyone wants to see what I'm going to do afterwards, you're welcome to stick around. Let me mute the audio here.